Hello calculus students and general seekers of truth. Welcome to the continuing series of videos on finding volumes of objects that have a known cross-section. And we continue with another example. This time, instead of using square cross-sections, we are going to use equilateral triangle cross-sections. Okay. So let me draw you the picture again. You have this base that is essentially a circle centered at the origin with a radius of 2. Okay. And then on top of this base, we are going to build a bunch of equilateral triangles. So I'll draw these in red. So we're going to stack up, these things are going to be sticking straight out of the paper. Okay. Now the distance of the side lengths of each of these equilateral triangles is dependent on where it is on the base. So if it's near here at 2 or near -2, it's going to be very small, and if it's towards the middle here, then it's going to be very big. So maybe we should talk a little bit about how to find the area of a equilateral triangle. So let's call one of these side lengths L. Okay. Now keep in mind that the area of the triangle is of course equal to 1/2 the height times the base, in this case L, right? But we have to relate everything back into L. So if you think about it here, this is H, and this little triangle here is a 30, 60, 90. The right triangle here, that's a 30, 60, 90 triangle. Okay, so I need to draw a slightly different picture here. Okay. So we have a 30, 60, 90 triangle. This length we already know is L because it comes from the equilateral. So if this length is L, that hypotenuse is also L. That means this length is 1/2 L, and that means this length is 1/2 L square root of 3. Okay. So the area of an equilateral triangle, and I'm sorry, this is a little bit messy, the area then is equal to 1/2 the base, which is still L, times the height, which is 1/2 L root 3. So you have 1/2 L times 1/2 L root 3. Okay? So putting all this together, we end up with 1/4 L squared times the square root of 3. Okay, so this is going to be very useful here. The area of an equilateral triangle is going to be this formula here, and this is an L, not E. Okay? I want us to confuse things. Okay, so back to this problem. Once we know how to find the area of one of them, we simply add up all of the areas, and by doing so, we are integrating from -2 to +2. The area of this thing, which is square root of 3 over 4 L squared dx. And L here is this length. That length right here is L. Because it's the base of the triangle and it's sticking straight out of the paper. Again, if you're having a hard time visualizing this, watch the previous videos that has some 3D animation and explanation for you. Okay, so L here is twice. L is equal to 2 times the value of y on the xy plane. Okay, because the y value is from this point up to here, and we're going all the way across. So this is 2 times y. Now this is, again, y is just equal to the square root of 4 minus x squared. So from this we can make our substitutions, and we're integrating between -2 and +2. I'm just going to pull the root 3 over 4 out to the front, and then we have 2 times square root of 4 minus x squared squared dx. So there's some simplifying here that should be done. So we have root 3 over 4 integral from -2 to +2, this is 4 times 4 minus x squared dx. This 4 and this 4 cancels, so we have the square root of 3, the integral from -2 to +2 of 4 minus x squared dx. Okay. So again, I am certain that you can evaluate this, but just in the interest of time, I'm going to speed it up and make use of my technology here in this particular video. And our final answer is root 3 times 32 over 3. Okay. So there you have it. Another example, this time of a slightly different object. So of a slightly different cross-section. So I will end this video here, and we'll start a couple more videos. Just again, these are applications, and with application problems, the more examples you do, the more comfortable you are dealing with this, if you get the basic understanding of the concepts, which in this case has to do with adding up an infinite number of areas. Alrighty, thank you for watching. Have a wonderful day. Remember to finish the rest of these videos.